Hello everyone, my name is Öykü and I'm a student from Department of Mathematics. In this video I'm going to explain the experiment that I conducted for Physics 101, which is called Investigating Motion from an Inclined Launch. First of all, I want to talk about the objective of my experiment. The main purpose of this experiment is to explore how the launch angle and initial velocity affect the horizontal distance of a projectile that is launched from an inclined plane. I'm going to also compare the experimental results with the theoretical predictions to understand the accuracy of the physics model and identify the possible sources of error. I'm going to talk about the materials that I use and procedure of the experiment. This is the list of materials that I use in my experiment. I use center platform to determine the position of the launch ball. This device you see here allows the ball to perform projectile motion along an inclined plane. First, I carefully adjust the inclination to the correct angle. Then, I place the ball inside the launcher and use a small stick to push it in and compress it. By doing this, I'm giving the ball an initial speed because there is a spring inside the device. And when the spring is compressed, it stores elastic potential energy, and when it is released, it converts that energy into kinetic energy, pushing the ball forward. Each time I make sure to compress the ball by the same amount because I want the initial velocity to stay constant for every trial. In other words, to keep the condition consistent and to make sure all the measurements are comparable, I always compress the spring the same way for each launch. And as you can see here, the ball leaves its mark where it lands. Thus, the final position is determined. Now I will talk about the data and errors I obtained. As you can see in the table, the physical predictions and the results obtained from the experiment generally agree. And since I used the sine formula when calculating the range, the largest horizontal change occurred at 45 degrees. As seen, also the values of the complementary angles are almost the same. As you can see in the table that I showed earlier, some errors have occurred in the experiment. This may be due to the air resistance that I was ignored in calculations, or to shift in the measurements caused by me. However, in general, the physical expectations and the data that I obtain as a result of the experiment has agree with each other. Thanks for watching me.